This screencast is about choosing the best multiple linear regression model. Choosing the best multiple linear regression model means choosing the subset of possible independent variables to best predict the dependent variable. Let's consider the magnitude of the problem. In simple linear regression, there are actually two possible models to estimate the dependent variable. The model that uses the one possible independent variable and the model that uses y bar. In a model with two possible independent variables, there are four possible models. The first uses both of the possible independent variables, and then there are two simple linear regression models that use either the first or second independent variable, and the fourth model is the model that uses y bar to estimate y. In fact, each time we add an additional possible independent variable, we double the number of possible models to choose from. In the example in this section, there are 8 possible independent variables, and thus there are 2 to the 8, 256 possible models from which to choose. And this is before we consider interaction or quadratic terms. There are two common procedures to aid the choice of the best subset of predictors. The first procedure is stepwise model selection. The second is best subset model selection. Best subset model selection is the best of the two methods, but it requires the use of dedicated statistical software. And not all statistical software is programmed to employ the method. At the end of this screencast, we'll briefly demonstrate the use of Minitab statistical software to choose the best model. The data on the left is associated with 25 sales reps in 25 sales territories. The goal is to predict sales in those territories based on a subset of the 8 possible independent variables. We will place sales in column A. Column A, sales, represents the total sales in dollars credited to the sales representative. The first independent variable appears in column B, time, the total time in months that the sales representative has been employed by the company. Potent refers to the market potential in units of sales in the territory. Advertising expense is the company's advertising expenditure in the territory. Share is the 4-year weighted average market share in percent for the territory. Change refers to the change in the market share for the territory over the past 4 years. Accounts is the number of accounts assigned to the particular sales representative. Work refers to workload. It's a weighted index based on annual purchases and concentrations of accounts in the territory. And the last potential independent variable is rating, a performance rating of the sales representative. As we sort through the possible models, we'll use 3 criteria. The first is new to us, the CP criteria. This is discussed in more detail in section 15.4. In this screencast, we'll simply state how we are using this criteria and then employ it to choose the best model. The second criteria we'll use, we're familiar with, the adjusted R-square. And finally, the third, the principle of parsimony, that says, all other things equal, fewer predictor variables is better. the way we'll use the CP criteria in choosing a model is we'll look for a CP statistic value that is less than or approximately equal to the number of independent variables in the model plus 1. So if we have a model with 2 independent variables, we would look for a CP value close to or less than 3. Now let's go over to Minitab and use best subsets to help us select a subset of the 8 independent variables that'll best predict the dependent variable sales. Now the full set of data is in homework 6, so I'm going to go over there, copy it off, open up Minitab, resize the screen capture, and I will be back here in what for you will be a moment. Welcome to Minitab. Let's paste in the full set of data. Our response or dependent variable is in column C1, that's sales. And our 8 potential independent variables are in columns C2 through C9. Let's go up to Statistics, select Regression and Best Subsets, and we'll tell Minitab that C1 sales, that's our response variable, C1, and our potential independent variables are in C2 through C9. Okay. And Minitab has looked through the 256 possible models and has reported the best 2 simple linear regression models, that is 1 independent variable model, the best 2 independent variable models, the best 3 independent variable models, etc., down to the one and only 8 independent variable model. And that 8 independent variable model would have an R squared adjusted of 88.3, R squared adjusted of 88.3. Now, when Minitab reports the best of the 2 models, it establishes best in terms of R squared adjusted. So you always see the highest R squared adjusted on top of the 2 specific models being reported. Now let's use the CP criteria to help us choose candidate models. Recall, we're looking for a CP value that is close to or less than the number of independent variables in the model plus 1. So as we make that evaluation, we're going to be adding 1 to the number that appears in this column. So 67.6 isn't anywhere near 2, so that's not going to work. In fact, as we go down to the column, the first one that has a chance of working is this 5.4 CP value, and it in fact is close to the 5 variables plus 1 value. So this is our first candidate model. It's the best 4 independent variable model. It has an R squared adjusted of 88.1, and it uses the independent variables in column, that would be what, C3, potent, C4, advertising expense, C5, market share, and C7, accounts. Let's continue down the CP list. The next best model that would satisfy the CP criteria is 4.4 is close to or less than the 6 variables plus 1 here. So that's another potential model. It's R squared adjusted 89.3 is about 1.2%. That's rather significant, higher than the 4-variable model that we had just looked at. The 5-variable model uses, what would this be, C2, 3, 4, 5, and 6, C2 through C6, time through change in market share over the last 4 years as independent variables. Continuing down the list, the best 6-variable model, 5.4, that satisfies the CP criteria. 5.4 is less than 7. The R-squared adjusted, 89.4, is very marginally larger than the R-squared adjusted for the best 5-variable model. In fact, my guess is as we look at these two models, the best 6-variable model uses the same set of variables as the best 5-variable model with one exception, this one. And I would bet if we fit that 6th variable model, we would find that accounts would actually come out to be an insignificant variable in the model. But we could try it. We could try all 3 of those models. I don't want this to go on too long, so let's make our best guess of a best model for fitting. And I'm going to pick up on this 5-variable model because it does have a substantial increase in the R-squared adjusted. Whereas even though there is a minor increase in R-squared adjusted going up to the best 6-variable model, the principle of parsimony is going to win out here and kick us back to the 5-variable model. So I'm going to just go ahead and fit the 5-variable model, which is going to use C2 through 3, 4, 5, 6, C6 to predict C1 sales. Let's ask Minitab to do that for us. Regression. Response variable here is going to be sales, C1. And the predictor variables are going to be C2 through C6. Let me check that. C6 is change. C6 is change. We got it right. Graphs. You know, we could pick up a bunch of other graphs, and I'll go back and get those if we need them. I don't think we'll go in that much detail, but this 4-in-1 graph will give us a reasonable amount of information, so we'll do that. Options. Well, let's print out the variance inflation factors. We know what that means. Durbin-Watson statistic, we know what it means, but there's no time order to this data, so that's kind of silly. Oh, let's stop there. Results. We don't need sequential sums of squares and so forth. Let's go up here to regression equation, table of coefficients, R-squared, basic analysis of variance. That's the ANOVA table. And we don't need to store anything, so we'll just go to OK here and see what we get. First thing we get is some residual plots. We don't need the histogram. There is no time order to the data, so we won't need this, what would be otherwise a time series plot. Here's the residual normal probability plot, which looks reasonable. And here's the residuals versus the fitted values, which looks pretty much like random scatter. That looks pretty good. So there's evidence here that this would be a reasonable model. We could do a little more residual analysis on this, but that'll do it for us right now. Let's minimize this. Here's the regression output that we had asked for. The estimated regression equation, the p-values for the independent variables, they're all very reasonable to include. We're not specifying a 5% significance level here, so that's fine. No significant collinearity. We've got what we expected, an adjusted R-squared of 89.3. You know, this is a very reasonable model. Let's use it. That will complete this screencast.